Hey everyone, it's Mr. Weaver, and I got another video for you. Today I'm going to be showing pre-drilling, and this is specifically when you're putting two pieces of wood together with a screw. So let's say, for example, maybe you're a sixth grader and you're going to be making a catapult or a trebuchet or some kind of medieval launching device. It's very common for kids to want to put some kind of vertical thing next to a horizontal, so you're almost making this perpendicular line here. And right now I'm just using scrap wood. So maybe this would go like this, and then you're going to have some kind of device here and a swinging system or whatever you're doing. But you need to attach this piece of wood to this piece of wood. And so you could nail it, but nails can come out. Screws are a little stronger. And so you want to screw this piece to this piece. In some cases, you could just stick this screw onto the wood and start screwing it either with a hand screw or a drill. And both of those options would work. But it's going to be a lot easier if you drill a starter hole, either known as a pilot hole or just called pre-drilling. And there's a couple of reasons why you do that. One is to make it easier for the screw to go through, but the other, and the more important reason, is so that you don't crack the wood. If you can imagine splitting firewood, you stick a wedge at the top and you pound it down, or like an axe. That splits the wood. And a screw is kind of doing the same thing. The little tip is like a wedge and it's pushing the wood apart. So you want to make sure you don't crack it. Now, reasons you might crack it include things like being so close to the edge that the wood is weaker, or just maybe you're using a harder wood that doesn't want to move around the screw as easily. And so the softer the wood, the more likely you can get away without pre-drilling. But if it's hardwood, you always need to pre-drill. So you basically are going to be using a combination of tools, or you could even eyeball it. But here's the general idea. This piece of wood that the screw is going through is going to have a hole that doesn't need to do anything other than make enough room for the screw to go through. So if I take a caliper, I could measure the diameter of my screw. I could find the matching drill bit. I could also kind of just eyeball it, which is more common. So if I look at this, that seems to be about the perfect diameter to let the screw go through easily. I don't even need to let the threads catch. So if I put this drill bit in, and again, whenever you're drilling, you're going to go into some scrap wood so you don't go into the table, or you got to go off the edge. So I'm going to drill down and do another one. Now I have a nice little hole. And if I put my screw through, I can tell just with my fingers I'm getting the screw to go through. So we know that that's a good diameter. You could even go a little bit wider so that the threads don't even catch at all. Get the correct driver bit for that screw. And now, when I attach this, it goes through this first piece very easily. And whenever I screw something in, by the way, I call these little squirts. And it's just like squirt gun. It's just little bit at a time, which makes sure you don't go too far, too fast, and crack your wood. And here's another little term for you. That is flush with the wood. That means it's flat with this other surface. That's called flush. And that's usually what you want. And so that's a pretty strong way. I didn't crack this wood. And like I said, you might be able to screw something in without cracking the wood. So I'm going to try that. And in this case, I was able to do that, but it's only because of the type of wood I'm using. If I would have used a hardwood, I might have split it. Or if I would have gone too close to the edge. And let's see if that happens here. When I go close to the edge. Now you can see that crack. And there's a couple reasons that might have happened. One is because it's too close to the edge. Two is because it's a harder wood. And three, it's because of the taper on this screw. You can see how it angles out like a wedge. So sometimes when you pre-drill, you might even use a special bit that has that matching taper. And so I'll put one of these in just so you can see the difference. Yeah, guy's coming off them. Now you can see that has a little divot there that matches the head of the screw. So when I put that in, it's going to match right there. Now, a couple other things to be aware of. Notice how I did not pre-drill into the second piece of wood, because that's where I want the screw to screw in and suck it up to this piece. And usually that's going to work. Every now and then you might need to drill into the second piece too. But if you do that, you need to make sure that you don't drill the same size hole, because then the screw won't fit tight, it won't do anything. It needs an even smaller hole. For the most part, things you're going to be doing in the Makerspace would only require a single pre-drilled hole into the outside piece of wood, not the bottom piece you're going into. So pre-drilling is just a nice way to, see all these? It's just a nice way to have your piece fit together easier, and you don't necessarily have to, actually that screw's too big, you don't necessarily have to have it be bigger than the bit, than the screw that you're putting in, but just having enough of a hole helps prevent this wood from splitting on you. And that screw was a nice flat-headed, pan-headed screw, which I didn't even have to put the chamfer bit on, and it just holds it together nicely. So pre-drilling is a nice way to help hold your screw in place while you screw it in and also prevent splitting. And that's it.